Hello everyone. In this tutorial, we'll be building a indexing service on Else blockchain where we'll be using this service to maintain account balances and transfer records for NFT issued data. The purpose of indexing service is to preemptively store data from the blockchain, such as transactions and different account balances, into a database so that if we need to fetch a huge amount of data, we can just fetch it from the DB itself instead of interacting with the blockchain in real time. So the difficulty level for this tutorial would be easy as most of the code will be present in the template itself. We'll just need to modify it according to our requirements. So moving on, step one would be to set up the development environment. For this, we need to install .NET 8.0 SDK and we need to install some tools such as VS Code, Visual Studio, Rider. So we can install any IDE of our choice. You can just go through these links and follow through them to install these tools. Next, we'll go to the AE Finder website for creating the AE Indexer template. So I'll just continue as guest for now for creating the template. We'll just name it NFT AE Indexer tutorial. You can ignore tutorial, just NFT AE Indexer and create save changes. So as you can see, our template has been built. Just click on this template. For next steps, we give a project name to our template and download the template. So here we can give the name as NFT AE Indexer. Download the template. I'll extract it here, copy it, paste it into my working folder. Yeah. Now we can move on to the next step. Next step would be, yeah, so our initial version of project structure would be looking something like this. So we can go through the project structure once. Yeah, so we have some contract files, we have some entity file, GraphQL files, some processor, and automate for profile and index modules. Yeah, so we have all the prerequisite things. Next, we'll need to add the token contract files, which will be used to interact with the multi-token contract for else. So for that, we'll need to follow this link. We can just uh, copy this, clone this repo. So the repo has been cloned. I'll go to the samples. Yeah, here I can see those two files. So I'll just select them, copy them, and paste it into my contracts folder. Yeah. So now I have these token contract files to interact with the multi-token contract profiles. I can move on to the next step. So next step would be, yeah, building model entities for our project. So we'll have two entity types, account and transfer record. For that, first we'll go to the entities folder and create a new file called account.cs. So we'll go to the entities folder, create a new file account.cs. Then we paste its implementation. Next, we'll need to build in similar way transfer record.cs in entities directory. So we'll just do that. Yeah. So I have added the transfer record also. Now, once we are done with this, we can start with writing our processor logic, which will contain all the functions which will be handling the different events that will be triggered when a transaction occurs on the blockchain. So, for this tutorial, first we'll create NFT transfer processor class inside our processors directory. So, I'll just create a new file NFT transferred processor dot cs. Next, I'll paste the implementation for it, which we have copied from the documentation. Once we are done with this, so I'll explain few of the things from this NFT transferred processor. So first is we need to define the type of transaction that is going to happen, which we are indexing. So for NFT transactions, we have assigned issued type as type of transaction or else blockchain. So mentioning this issued type in log event processor base defines that we'll be tracking only NFT transactions. For normal token transfers, the type would be transfer. So that will have different type of variable, which you can go through else.contracts.multi-token instance, which will be present in these files that we copied in here. These files are generated from proto files for a multi-token contract. So these are just derivative files. And I'll try to explain some of the functions like we use this process async functions, which will be triggered every time a log event comes. And here we define what is the chain ID. And based on that, we'll get what is the address to interact with that chain ID. Then we save those transfers. We update the account balances for those. We fetch some data related to that token info. Yeah, so that is pretty much it. Also, we have defined some conditions for validating if that is a NFT transfer or not. So you can go through the code if you want to dig a little deeper. Next, we need to create some functions for GraphQL so that the response we get from data objects can be passed into GraphQL understandable syntax. So we'll create some tier classes for account entity and transfer record entity. So first we need to go to the GraphQL directory and there we'll create this account dto.cs. I just minimize these directories and we'll go here. We'll create a new file account dto.cs. We'll paste the implementation for it. Similarly, we'll be creating a transfer record DTO. So transfer record dto.cs. Paste the implementation for it. Next, we have something called get account input. So we'll create a new file, get account input. These are just model classes to pass different types of data while interacting with GraphQL queries. So that's why we are building these. Then we'll build a new class called get transfer record input. Get transfer record input is the implementation here. Next, we need to write the query logic for QL syntax so that we can fetch whatever required data we need from after it has been indexed through the service. So we'll copy its implementation and paste it in the query. So we have a query.cs file inside GraphQL directory. Just paste the implementation for it here, and you'll be able to generate all the queries related to data that we need. Yeah. So that's pretty much it, I think. Once we have implemented the query part, we need to register the log event processor to our indexer modules. For that, we'll copy this implementation. So basically, we'll be adding this particular NFT transfer processor that we created, and we'll add this to the list of services as a singleton. So we'll go to the NFTA indexer module. We can find it here. We'll paste the implementation for it, and our NFT transfer processor would be added to the services context. Then we'll update the mapper profile so that account and account DTO classes can be mapped one to one. So here we go to the auto mapper profile, update it, and save it. Once we have done this, we are ready to build the DLL file for this project. So I'll just go to the main directory, then start the build process. Okay. We just need to be present in the root directory for the build process. Yeah. So now DLL is being built. We'll just wait for a few seconds. Our build has been completed now, and the required DLL file has been generated. So we can see it here in the bin release folder. This is a main DLL file that will be used for indexing the transactions. So next step will be to use this to deploy it on A Finder. So we'll go to the A Finder. We'll go to our project. We'll click this deploy button. Here, what we need to do is we'll need to provide a subscription manifest, which is just a JSON which describes some properties for the indexing service, like what chain ID do we need to index, what should be the start block number, and should we include only confirmed transactions or not. Other than that, we define some other things like contract address, event names. Here we can define the type of transactions that we want to fetch, like issued or issue, which in the case of it represents NFT type transactions. So we'll just copy the subscription items and we'll paste it here in the manifest JSON. Next step would be to upload the DLL, which contains our required code. So we'll go to the generated DLL directory, event release. Yeah, here we have our DLL. We'll upload it. We'll click on deploy. Oh, okay. So now our DLL has been uploaded successfully and we have started the deployment. So now we'll be able to see some logs like this. So yeah, they are able to fetch different types of logs. Also, you can use these filters to filter out certain type of transactions. Like if we click debug, it might take some time. Yeah, here we can see all the transactions like NFT balance has been changed for this account. Uh, this account, this is the token info for SCR 8563. So here we can find all the related transactions. Now, once have started indexing data, we can use this query to filter out type of data using this GraphQL query that we require. So I'll just try to execute it here so that we can get an idea how it works. So here I have defined an address to filter out, but for this tutorial, I'll just remove this and just filter out all the transactions with chain ID TVW and we'll execute it. Yeah. So here we can see that we have got all the transactions and account data where the chain ID is TDBW. Yeah. So in this way, you can index blockchain transactions successfully into a DB and query it through a language like GraphQL. With this tutorial is complete. Yeah. Congratulations. So our next steps would be to use this indexing service data in our DApp, which you can follow through this tutorial NFT DApp. Here we have already covered how to build and deploy a NFT collection through front-end UI. So you can follow through the steps given here, or you can follow the steps that are given here. Both are same. So we are just building out a front-end UI for NFT creations and storage, where we can connect to a Protkey wallet and create an NFT, and we can list down all the NFT associated with our account. So you can go through these steps if you want to, or you can look through the tutorial given on this NFTD app page. Yeah. So that's it for now. Congratulations. You have successfully built an indexing service and through which you can store huge amounts of blockchain data and query it's in short amount of times so that you can scale easily. Yes. So we are pretty much done with this tutorial.